Alright guys, let's get into the Unit 5 review. This shouldn't take forever because we're just dealing with radicals and exponents, which isn't terrible. On number 1, when you square a square root, they cancel each other out. However, on this one, on number 1, right, if you were to just go ahead and square that, that would give you a square root of 100 because that square is going to take care of the negative, right? And then you take the square of that, you get positive 10. So you could go straight to the 10, right? You just need to know that the square is still going to have an effect on the negative even though it gets canceled out. So it's a bit of a nuance there, but that's the idea. Okay. On number 2, again, square has an effect on the parentheses itself. In this case, it's going to result in a positive number regardless of what you plug in there. So you got x minus 6. So if I plugged in 0, that would be a negative 6 on the inside, but the square would take care of it. So the square root is going to take care of the square, but the square also has an effect by making everything positive on the inside. So how do you write that? Well, what else is always positive? Absolute value. So anytime you see something similar to this, you take the absolute value of what's inside. And this is only true if you have an even root. If you have a cube root, then it's just straight up. On number 3, you need to factor the inside first. So that's going to be x and x plus plus, and that's going to be 8 and 8. So that's the same thing as x plus 8 all squared. And then once you get to this part, it acts just like number 2. So my final answer is going to be the absolute value of x plus 8. On number 4, you have the cube root of 27. Well, the cube root, you can take the negative of it. So like on number 5, you can take the cube root of that. But on number 4, no matter what you get, the answer is going to be negative, or at least you're going to take the opposite of, because the negative is on the outside. So this, the cube root of 27 is 3, and it's going to be a negative 3 because of the negative on the outside. On number 5, the cube root of 343 is 7, but because it's negative, it's going to be a negative 7. Here, when you raise a fraction to a power, you give that power to both the top of the fraction and the bottom of the fraction. You do the same thing, you take the root. You take the cube, we're going to take the cube root of 1 and the cube root of 27. You don't have to split it up, but you can if it helps. But this is going to be 1 over 3, and that's all there is to it. On 7, the cube root of 64 is 4, and that negative is going to be going to make it negative 4. On 8, I can find the fourth root of 256, and if you need to use your calculator, you can. But if the negative was on the inside, this whole thing would fall apart because I can't take the even root of a negative number. But because the negative is on the outside, I can find the fourth root and then just make it negative. So this is going to be negative 4 because the fourth root of 256 is 4. Okay. On number 9, you got the eighth root of x plus 2 to the 8th. So this acts just like 2 and 3. Right? The eighth root, the even root, is going to take care of that. The eighth root is going to take care of the eighth power. But the eighth power also makes everything positive. So this is going to be x plus 2 and the absolute value of x plus 2. Okay, on 10, I'm dealing with an odd root. So this one, I don't have to worry about absolute values or anything like that. The cube root of negative 8 is negative 2, and then the cube root of x plus 1 cubed is x plus 1. So it's just going to be negative 2 times x plus 1. Now, you could distribute that if you wanted to. It's not necessary. Now, when we get to number 11, we're taking the cubed root of 64, and then we're going to square it. So remember, I can take this fractional exponent and rewrite this whole thing to be the cube root squared. So that's another way of doing this. And the cube root of 64 is 4. So this is the same thing as 4 squared, which is 16. On 12, 125 to the 4/3 is the same thing. I'm going to take the cube root of 125 and I'm going to raise it to the 4th power. Okay, well the cube root of 125 is 5. So this is 5 to the 4th, which is 625. Again, you can use your calculator to help you out with this stuff. On 13, you can do this where you're doing the exact same thing. The cube root of negative 27, and that's going to be squared. The cube root of negative 27 is negative 3, and if you square it, you get 9. On 14 and 15, you're doing the exact same thing, but there's no solving. There's no finished product or anything like that. You're just going to rewrite it in terms of fractional exponents. So on 14, I'm going to rewrite this as x to the 4/9, x to the 4/9, and then in 15, I'm going to rewrite this as 8 to the x squared y, put it in parentheses, 7/5. Okay, easy peasy. It's just a simple rewrite. Okay, on 16, now we have a negative exponent, and so I'm going to deal with that first. And just like before, I can take that fractional exponent and write it as a root. So this is the same thing as saying 1 over the square root of negative 1. Right, the 1/2 turns into a square root, but the negative is what brings it down to the denominator. Well, the square root of 81 is 9, so this answer is going to be 1 over 9. On 17, that negative exponent is going to bring it down to the bottom, and so this is going to be 1 over the cube root of negative 27 squared. Okay, so the cube root of negative 127 is 1 over negative 3 squared, and it also is going to be 1 over 9. On 18, the way you deal with the negative is you essentially flip the fraction. So this is going to be 64 over 27 to the 1/3, and then the 1/3 just means I'm taking the cube root. So you can take the cube root of 64 and the cube root of 27, and that's going to give you 4 over 3. On 19, when you raise the power to, when you multiply like basis, you add the exponents. So when you add the exponents here, you got 3/8 and 5/8. It's going to be 8/8, which is 8/8 is x to the first, so that's just x. On 20, when you raise the power to the power you multiply, so you got b to the 5th times 2/5 times 2/5, and remember those cancel, so I'm just left with b squared. Okay, on 21, when you multiply like basis, you add the exponents. And these exponents do not have the same denominator, so I need to get the same denominator. So 2 and 3, that's going to give me a denominator 6, so it's going to be 3 over 6 times x to the 10 over 6 over x to the 4/7. Now, we are going to have to deal with that 4/7 not being the same denominator eventually, but we can do that next. Okay, so that's going to be 13 over 6, x 13 over 6 over x 4 over 7. Now, I need to count denominators again. That's going to be 42. So x 42, 6 goes into 42, 7 times 13 is 91. 7 goes into 42, 6 times 4 is 24. And now subtract. Okay, so this is going to be 91 minus 24, which is 67. So this is going to be x 67 over 42. So, bit of a process. You could have got the common denominator 42 from the jump. That would have taken you a little less time to get to the end of this problem, but that's how you do it. All right, remember this fractional exponent is the same thing as the root. So on 22, I'm taking the square root of that entire thing. And if you need to write it like that, that's fine. So I'm taking the square root of the entire thing, 64, x to the 4th, y to the 10th. And so the square root of 64 is 8. And then when it comes to taking the square root of exponents, if they're even, you're just taking half. So this is going to be x squared, y to the 5th. So that's my answer here. On 23, this one's interesting because I can rewrite the inside of this. This is going to be 15 through. I can rewrite this as 3x all cubed, because 3 cubed is 27, so I could rewrite that as 3 cubed, and then I can bring that cubed out and write that in parentheses. And then, if I do it like this, I can rewrite this as 3x to the 3 over 15. Well, 3 over 15 is 1/5. So you can simplify that 3x to the 1/5. And then if it's written like this, you know that this is the same thing as your original. The 5th root of 3x, which is what your answer is going to be. So sometimes it's just a matter of simplifying. It's not really, it's not so much an answer per se as I did a little simplification, a reduction, if you will. On 24, this is the same thing as xy to the 10 over 5. Well, 10 over 5 is 2. So that's xy squared. And you can leave it like that, or you can say x squared y squared. But we're going to leave it like that. Okay, on 25, when you get to radicals and you're multiplying, you multiply the insides together, you multiply the outsides together. And here, this is simply going to be the square root of 6. Sometimes you can go a little further and simplify, but this is as much as you can do here. Here, on 26, you have x minus 2 to the 5th and x minus 2 to the 1st. When I multiply these two together, because they're both the 7th root, this is going to be x minus 2 to the 6th. All right, and that's as far as I can go. But it's still, I have one radical instead of multiple. Now, starting with 27, I can rewrite these to simplify the radical. And it's kind of like simplifying the fraction, reducing a fraction into simplest terms. You have, if you can write a radical in simpler terms, you have to. Okay, so this is where knowing your perfect squares and your perfect cubes it really comes in handy. But here, I can rewrite 18 as 9 times 2. Well, I can separate those two and say 9 square root of 9 times square root of 2. And then I can take the square root of 9 and say 3 square root of 2. And these two, 3 square root of 2 and square root of 18, are the exact same thing. They'll give you the exact same decimal, right? But 3 square root of 2 is the simplified version of this radical. All right, cube root of 256. Well, I don't know the cube root. 256 doesn't have a cube root, so maybe I can simplify it. And it turns out I can take the cube root and do 64 times 4. Well, the cube root of 64 is 4. So I can say 4 times the cube root of 4. And that's the simplified version of what I started with. I have on 29, I have the square root of 125x cubed. Well, I can take a 25 out of the 125, and I can take an x squared out of the x cubed. So I can rewrite this as 25x squared times 5x. All right, and when I take the square root of that first part, the 25x squared, that's going to leave me with 5x on the outside, and then 5x is also on the inside. And so that's going to be our answer, 5x times the square root of 5x. Okay, 30. Okay, so here I'm taking the cube root of everything. And so here, the cube root of 81, I don't know that off the top of my head. All right, it doesn't have a straight. 27 times 3, 27 is a cube root, but 3 is not. So I get 27, and then x goes into 11 3 times. So it's going to be x to the 9th, and then y to the 9th. And I can multiply that by 27 times 3 is 81, and then x to the 9th times x squared. And so when you break apart everything, this is what you're left with. You have 27, x to the 9th, y to the 9th. That term is your perfect cube. And so that's what's coming out. I'm going to take the cube root of it. So that's going to be 3x cubed y cubed times the cube root of 3x squared. Okay. And there you go. On 31, you're going to multiply before you simplify. 18 times 6 is going to be 108 xy. And so when I do that, that's going to give me, I need to simplify that. And you can do this in part or in whole, but the biggest perfect square that goes into 108 is 36. 36 times 3, and the xy, I'm just going to put with the 3. And so it's going to be 6 square root 3xy for my answer. Okay. On 32, this is going to be the cube root of 40 x to the 23, y to the 8th. Okay, the cube root that lives inside of 40 is 8. So I can take the cube root, and that's going to be 8. 3 goes into 23. It goes into 21, not 23. And then it goes into 8, 6. And so 8 times 5 is 40. And then it's going to be x squared and y squared. That's going to be 2 x to the 7th y squared times the cube root of 5 x squared y squared. Okay. Now, when it comes to adding and subtracting radicals, you want to make sure that the radicals are the same. So on 33, this is simply 5 squared root of 7 minus 8 squared root of 7. So because the radicals are the same, I can work with the outside numbers. So 5 minus 8 is going to be negative 3 squared root of 7. That's it. On 34, you have 2 different radicals, but I can combine some of these. You've got 8 squared root of 2 minus 7 squared root of 2. That's simply going to be square root of 2. And then the square root of 13 is just going to hang out. So there's that. So you combine what you can, but you can't always combine everything. On 35, I need to simplify these before I can add and subtract. So 28 is going to be 4 and 7. And then 343 is going to be 49 and 7. The square root of 4 is 2, so it's 2 squared root of 7. And the square root of 49 is 7 square root of 7. So 2 square root of 7 minus 7 square root of 7, that's going to give you negative 5 square root of 7 is your answer. Okay. On 36, I can take out a 4 on the inside, that's going to give me x plus 1. And then I can take the square root of 4. We take the square root of 4, and that's going to give me 2 radical x plus 1 plus radical x plus 1. So now I have 2 x plus 1 and 1 x plus 1, so it's going to be a total of 3 square root x plus 1. On 37, we do the exact same thing. All right, so it's going to give me 8 is going to be on the outside. That's going to be 64 times 2 minus 3. That's going to be 49 times 2 plus 4, and that's going to be 36 times 2. When I take the square root of 64, that's going to be 8, and I multiply it by whatever's out there, in this case 8, so I'm going to have 64 on the outside, square root of 2, minus, when I take the square root of 49, it's going to be 7, 7 times 3 is 21, so 21 square root of 2, plus square root of 36 is 6, 6 times 4 is 24, square root of 2, and then you can do that in the calculator, 64 minus 21 plus 24, that's going to give you a total of 67 square root of 2. Okay. Now, on 38, remember that you can split this up and take the square root of 48 and the square root of 49. Well, the square root of 49, you know, is going to be 7. And you can simplify the top. And, that's going to be 16 and 3. I can take the square root of 16. So that's going to be 4 square root of 3 over 7. And there's your answer. Okay, on 39, I know the square root of both of those. So that's going to be 3 over 7. So there you go. On 40, it makes sense on this one to put them back together. So like on 38, I split the radical up. On 40, I can put it back together just as easily. So this is going to be the square root of 120 over 5. And that's going to be the square root of 24, which I can simplify a little further. 4 goes into that, so it'll be 4 and 6. It's going to be 2 square root of 6. Okay. 41, I'm put them back together, simplify, so this is going to be 14xy cubed over 7x. And that's going to leave me with 2y cubed underneath. Okay, well, I can't take the square root of 2, but y cubed under a square root, I can take that out. So that would be y. I can separate that as y squared times 2y. And that's going to be y square root 2y. Okay. On 42, once again, I'm going to put these together. So I get the cube root of 250 a to the fourth, a to the sixth, 2a. And that's going to give me 125a cubed, b to the sixth. Well, when I take the cube root of that, every bit of that is a cube root. So this is going to be 5ab squared. Okay, and then on 43, I'm going to distribute all this. So this is going to be, when you multiply radicals together, multiply the insides, this is going to be square root of 21 minus the square root of 35. Right? And there's nothing I can do there, but that's your answer. On 44, we're going to distribute with FOIL. So you got 4 times 2 is 8. 4 times 2 squared root of 5 is 8 squared root of 5. 2 squared root of 5, or 2 times square root of 5 is 2 squared root of 5. And then 5 squared root of 5 times, it's going to be 2 times square root of 25. So let's clean this up. It's going to be 8 plus 10 squared root of 5 plus square root of 25 is 5. 5 times 2 is 10. So it's going to be 18 plus 10 square root of 5. Okay. I can't emphasize this enough. When you see problems like 45, please go ahead and write them out. This is 3 squared root of 5. This is 3 squared root of 5 plus 5 twice. And I say this because if you don't write it out like this, you will forget that middle term 9 times out of 10. So when you multiply this out by FOIL, 3 times 3 is 9. Square root of 5 times square root of 5 is square root of 25. And that's going to be 15 square root of 5 plus 15 square root of 5. And then that's going to be plus 25. Well, square root of 25, like before, is 5. 5 times 9 is 45. And that's going to be 30 square root of 5 plus 25. 45 plus 25 is 70. So you got 70 plus 30 square root of 5. Now, with 46, we're rationalizing the denominator. You can't leave a radical in the bottom of the fraction. So I'm going to multiply by what it needs to complete the root and come out. So here, that 2 needs to be a 4, so I'm going to multiply by 2, square root of 2, and then x needs to be an x squared, so I'll multiply by square root of 2x. And whatever you do at the bottom, do the top. So this is going to be square root of 2x on top, over square root of 4x squared on the bottom, and square root of 4x squared is simply 2x. So it's going to be square root of 2x over 2x. Okay? Easy peasy. Now, I explained it to you that way because when you get to 47, I don't need cube root of 5. I need to figure out what does it need in order to be a perfect cube inside. Well, 5 is 5 to the first. I need 5 squared. So this is going to be the cube root of 25. I'm going to do the bottom, do the top. And And again, I do this because when I multiply these together, this is going to be the cube root of 25 on top and the cube root of 125 on the bottom, which is a perfect cube. So this is going to be the cube root of 25 on top over 5. So I want to multiply enough. I want to multiply by enough to get a perfect cube, a perfect square, or whatever to show up, so that I can get rid of the root in the denominator. Okay. All right. 48. Let's see. We got. I'll take the cube root. Again, I'll split this up. So the cube root of 4. I get the cube root of 9x squared. I don't need much on the bottom, but I do need something. Let's see. 9 is 3 squared. I need another 3. This is going to be the cube root of 3. And x squared is really close. I only need one more x. So I'm going to multiply by the cube root of 3x. So on top, that's simply going to be the cube root of 12x. Because 4 times 3x is 12x. And then on the bottom, it's going to be the cube root of 27, x cubed, which is a perfect cube. So this is going to be the cube root of 12x over 3x. Right, 49. So again, my whole goal here is to get rid of the radicals in the bottom. So on 49 and 50, I have to multiply by the conjugate, which here is going to be 7 plus square root of 2. So it's kind of like that whole difference of two squares things from chapter 6, from the last unit. So whenever you're multiplying like this is going to allow you to get rid of any middle terms, and it will force all your radicals to fall out, which is what I want to happen. So this is going to be 4. I'm going to just leave this on the outside, 7 square root of 2 over, and that's going to be 49. Again, the middle term's going to go away, so you're essentially squaring your last term, squaring your first term, squaring your last term. So that's going to be minus 2. So it's going to be 4 square root of 7. 4 times 7 plus square root of 2 over 47. Okay. One more. 7 minus square root of 6. 7 minus square root of 6. Okay, on top, that's going to be 49 minus 7 square root of 6 minus 7 square root of 6. Plus 6 over 49 minus 6. So it's going to be 49 plus 6 is 55. It's going to be minus 14 over 6 over 49 plus 43. And there's your answer. Alright guys, hope that was helpful for you. If you have any questions, please reach out. And I'll see you in the next video.